Alright, we have one last topic to talk about. That is, when does a function have an inverse? Alright, so remember that a function, right, is a set of inputs with the rule that every input has only one output. Has only one output. Right? And that means that if I look at my inverse function, right, if we think about the inverse, our main rule is that inputs and outputs switch, inputs, outputs switch. Right? This is the main rule of inverse functions here. Right? And so here, if I read this statement, right, but for inverses, so if I have inverse function, inverse function rule, right, I'm just going to switch this, switch where it says output and input. So I read it as every output has only one input, has only one input. And that is, in fact, the rule for a function to have an inverse. Right? So if a function follows this rule, right? So if a function follows this rule, oh no, I wanted to say this rule, then it has an inverse function. Then it has an inverse function. Has an inverse function, right? So if it follows the rule that every output only has one input, it has an inverse function. So graphically, so we said that a regular function rule, we have this vertical line notation, this vertical line test rather. So if we have a function, or something we're thinking maybe is a function, right, we should be able to draw a vertical line anywhere. It only passes once. So this is a function. But this, if we draw a vertical line here, we pass through more than once, and so we're not a function. Right here, right, we can still draw maybe that exact same function, and then maybe we'll draw a different function. The function looks like that. Right here, every output has one input means the opposite, right? Here we're looking at vertical lines because we're saying the input is unique. Here we're saying that the output is unique. And so instead of being a vertical line, we're looking at horizontal lines. So we have a horizontal line test for this one. And so here, this first one, even though it's a function, it doesn't have an inverse. So there's no inverse for this function. But here, we can draw horizontal lines all we want, and we're only going to cross once. And so here we do have an inverse. Here we do have an inverse. Or we should say, like, has inverse. Right? And more importantly, when we say something has an inverse, what we mean is that if we were to find it, it would be a function. Right? Just like when we have the opposite of multiplication is division, so we have like x divided by 5. Right? We're dividing by a number. Right, we take one number divided by another number. When we have a function, we want to find its inverse. We want to make sure that its inverse is also a function. Right, so this ensures, right, this means, right, the inverse is also a function. Also a function. And we call it, so we call such functions. So we call functions with inverses and verses. We call them 1 to 1. 1 to 1. And what that represents is one output to one input. Right? Every element in the output only goes to one number. Every element in the input only goes to one number. They're linked together. They're 1 to 1. That's what we call them. So Maybe we'll stay on this video, we'll switch up the paper here, and we'll just do a few like graphical examples here. So if I look at maybe our good friend x squared, right? We're a function because we passed the vertical line test, but we're no inverses, right? So we're a function, right? But no inverse, no inverse. If I look at another function we know from this class is 1 over x, right? It's a rational function that looks like this, and it goes down like this. Here we can draw vertical lines anywhere. We can draw horizontal lines anywhere. Notably, if we draw a horizontal line at the horizontal asymptote here, the function's not actually there. And so it's not crossing where the function's at. And so here we are a function. So we're a function. We have an inverse. And we call ourselves 1, 2, 1, using the same terminology here. A function we're about to encounter in class in our next section is exponential, so like 2 to the x. That's kind of the shape I drew earlier. We're just going up for a long time. It has one horizontal asymptote but no vertical asymptote here. Here, again, we're also a function. And we'll also have an inverse. We have an inverse. That is a function, so we're called 1, 2, 1. Right. Just to look at to step back and look at a more basic function. If I had something like 3x plus 7, right, that looks something like this, probably steeper than how I drew it, but generally speaking a line, right? We still can we can pass our vertical line test, and we can also pass the horizontal line test. So here we are a function, right? We are a function. We have an inverse, right? And so again, we are 1 to 1, right? So that's just a few examples of functions. And again, you're just looking to see if they pass the horizontal line test or if they pass the vertical line test. And if they pass both, they're 1 to 1. If they only pass the vertical line test, they're a function. If they don't pass the vertical line test, they're not a function. And so that's wraps it up for inverses. I'm sure we'll have to talk on Tuesday about this all again, but hopefully this will be enough for us to kind of work through the problems themselves.